So hello everybody, the visitors, the YouTube visitors actually. So it is the Holochain-in-Action number 6, and some of our friends from a community here. Also today we have 2 new members. Hello to them also. Thank you and warm welcome. So before starting the content of today, a couple of small actually notices. First, subscribe and share the video for a knowledge sharing about the Holochain. So, if you would like to learn about the basic concept, please review the last video, data structure in Holochain as a basic concept. And I did a little bit refactor with Nick. So for the unit, for the testing and multi-agent, we are gonna review them. And the rest that in the video, in the description, you will see a bunch of link in a gym, in the forum, and for the link, if you would like to be inside this meeting is longer than the recorded video. You need to fill out the application form. The link is in description. And today we are going to cover number 1, a design to see how peer share and the design we are going to work as a JSON schema pattern that we need to have a good name for it. And I decided that let's go for the JSC pattern, JSON schema pattern. What does it mean? What we are going to implement as a peer share and introduce a JSON schema pattern, how it can help us. And then we are going to talk about anchor pattern. What is anchor pattern? Why we need anchor pattern in Holochain application? And then we are going to implement the first, to complete, I think we started implement. Yes, we did the schema as an entry, and we are going to make it compatible with the JSON schema. It is the content for today and paid program. So let me share my video and go for the first step, which is peer share and JSON schema pattern and why we need it, how it's supposed to help us actually. So do you see my screen, guys?
Yes.
So it is the way that a normal Holochain application is supposed to be working in Holochain. It means in a design time, you create a one entry definition as a struct or as a struct with your properties and field you would like. Just imagine it is the application for a post and blog, something like that. You're going to create the entry, define the entry, post title, post body, hook, post created at the data time, or other field that you would like. When you implement your application, you publish as a DNA. This is the DNA of network. So agents, it means a user via UI application, are going to inject or create some entry. For example, it is my blog post, the title is this one, it is the body created at this one. They create a one entry and add to the DHT, distributed hash table. So it is a normal way you are supposed to implement your application in Holochain. So what is JSON schema pattern or JSC pattern? We are going to call it JSC. It is this pattern that we are going to implement this one. So, okay, let's see what is this pattern and compare. So in this pattern here, instead of creating entry as a concrete field, we are creating a fixed entry as a definition, JSON definition, version of this schema, and the owner, which is developer. And we already learned how to implement and detect the user of the system as a developer and non-developer. If you have some question or you didn't get it, please go back to previous videos. You can find the link also as a playlist. By the way, so we can create abstraction of a schema as a fixed entry in application. Then in a design time. So in a runtime, developer create one entry as a schema with JSON schema. So as you can see, here we can define a property based on the JSON schema. JSON schema is the standard that it's going to actually help to create a schema instead of have a concrete to have a dynamic with some validations. We can run it. It is a JSON schema. You can go to the JSON schema org and read about that. So runtime developer create one entry and name it schema version 1. And other agents that would like to, for example, create a post, they create the schema JSON via UI. UI is going to provide this facility that create a post in a JSON format and inject to the DNA, referring this schema that, hey, the data I'm going to inject, it is for this schema. And for sure, we are going to implement validations. It means the schema that we are receiving, it should be validated because JSON schema standard providing some validation. It should be validated. And we will see, you will see, and actually together we are going to implement some tests if it is a valid JSON schema or invalid. And also the data is going to be validated using the JSON schema and the schema that the developer created. So while we created the heart a little bit complex and a little bit harder than normal, it is the way DNA at the end, it's the hash code. It means at the end of the day, all the logic that we are writing, which is supposed to be compiled to WebAssembly, it's going to be generated as a hash. At the end, the application produces a hash. So when the agents are running the same hash, they can see each other, they can play the role in the same DHT. It means nobody are supposed to touch the application. Otherwise, you are going to be isolated from the network. It means we trust that we are running the same application and same business rule. So just imagine you would like to change something here. You would like to add a new property. So, hey, Thomas. So just imagine we are going to add a new property here, huh? So in the normal way, if you are going to touch your source code, it means a new hash entry. You need to publish a new application version. So you need to migrate from the old version to new version. There are processes, there are some hassle that it is not a really easy job. There are some steps you need to do, but you need to migrate easily. In the world with the DevOps, a lot of change, you did some mistakes, something like that. All the business rule is here. As soon as you are going to do a small change, you need to go for the versioning. Versioning is not as easy as centralized application actually. In the peer-to-peer application, versioning is not really easy. But in this format, in the JSC pattern, JSON schema pattern, you can easily, if you implement something, you want to add a new field, you don't need to touch your code. You create a new schema, you publish, you add a new schema version, and you are changing your UI and telling, hey, instead of just accepting data for the old schema, please accept for the new schema and publish. So if you need to do some changes, add new extra field, you do not need to touch your source code. So it means you are safe enough to continue. For sure, there are some steps in your application, you would like to do some changes, add extra business logic, there are some bugs, it can happen, but not actually daily basis. For a daily basis, because JSON schema provides some business logic, like a validation, something like that. So in that case, we can say for small changes, new properties, something like that, or a validation, you can be safe enough to do change without any version. It is the reason of JSC pattern or JSON schema pattern that we are going to use it as an example in PShare. It means PShare as a use case of a JSON schema, it is the things application we are going to focus on and we are going to work on it. So far, is there any question? You got the point why we are going to work on a JSC and what is the reason? If there is any question before continue, let me know that I can answer. So, and that is great. We can go and start for implementation of something. So let me pause the video, open the project, and then come back. So we are gonna continue implementing the actually schema based on the explanation I mentioned, because we implemented one entry. Last week we learned what is the element, header, and entry. So we implemented a schema as an empty version. Right now we are going to continue that implementation. So guys, it is the project. The URL to this GitHub repository, you can find it in the description. Anytime you would like, you can go, you can play with it, you can change it if you think you can improve something or you can add a new extra functionality to it. Please go and do it and send a pull request and I will review and we can talk about it. So, by the way, thank you to Nick, and I'm not gonna go too detailed right now, but we had some change. Let me mention, maybe some of you are looking at the project. As you can see, I implemented something here based on the discussion we had last time with Nick. So it is about installing multi-agent for the app. Previously, we had the issue here. It means if we would install, if you would like to have two agents, they were working on two different DNA. It means they were standalone. But in a reality, in a test scenario, we would like to have a one DNA as a one application with a different player or different agents. So we didn't have that one. So for the rest of the implementation and the session, this and the future session, we really need this scenario. And that's why I implemented this version. I'm gonna go into the details for this one, but as a beginning, if you would like, or you are implementing any application, you would like to have a multi-agent, you can come here in the common test. In this repository, you can find it, PShare, in Holochain-in-Action, in common, and here install agents app. So this one is installing two agents, actually. One as a developer, one non-developer. And it is the test, you can run it. So I open the project. If I go to the, let me show you how to run this project. You install the Holochain infrastructure. So you can find the forum, go to holo-layer, type Nixshell. You need to have Nixshell actually. And run the test, that's it. So let's go to the entries. So we are going to improve the schema. So what we have here, I'm in the Nixshell environment. You see, I go to the test and npm test. So while it is working, I'm going to continue the job we are going to do actually. What we are going to do, so we are going to continue a schema. So what happened previously, we created a schema. So, and you saw that for the schema, actually, we created just empty schema. What schema we created? Do you see the definition, version, and actually we created this one. We created this one, definition, version, and owner address. But we didn't validate that the string as a definition. We didn't start implementing any JSON schema because we need to validate right now. Actually, developer can send any definition as a string, like we have here. Look, we have something like we can send a schema test. What did I send? Actually, I sent fake data, but it is not supposed to be this one. It's supposed to be this format as a schema, and then we need to evaluate that it is correct or not. So first of all, we need to use a caret to validate JSON. So here I'm going to implement helper as a, actually, let me call it parser. Parser. What is the parser? We are going to see. First of all, for using any third-party library, you are coming from a different world, like .NET or other world. You need here in the ROS, it is a caret. We are going to use a third-party library that for the JSON schema to have it up and running, we need these two carets actually. JSON schema / valid this version and server.json underscore JSON actually. So we need these two carets for the evaluating JSON. For the JSON schema, there are a bunch of carets. I tried a few of them, but the most handy and a ready one that I could use, it was this one. Any feedback you have, please. If you would like to improve it, warm welcome. So let's go to the parser and let's start implementing the parser. So since I already implemented the parser, I'm going to save the time to tell you that what we are going to have, we are going to have something like that. It means we are going to receive a validate schema as a JSON schema and to return back a bool. It means the schema that we are receiving as a string, it is valid or not. So let me, to speed up, let me copy the code here. So I don't think so there is any need to explain a lot about this code. They are just coming from the caret that it's explained there. So it is the validate JSON. It's converting the input parameter as a value and from a config from a schema. So what is this one? It means which caret supposed to convert. It is this two one. So serve the JSON is a value and a JSON schema is config. It is the actually function from a config that validating if the input parameter or string is valid or not. That's it. And it is for a validate schema. And also we need to have another function for validate data. What does it mean? It means if I would send, do you remember here, when in the runtime, user is going to inject some data. So it's supposed to say, hey, I'm sending you a JSON data, which is related to this schema that developer created. It means then later on, we are supposed to validate the data that's coming. It is compatible with the schema that developer created. JSON schema has this kind of nice actually pattern that we can evaluate. We need that code also, and it is for that one. Validate data, receiving a schema JSON and data. And then with this code, it is telling it is valid or not. To review, we are converting everything to actually value of a JSON. And then again, there is a function in the caret that telling this data is valid or not. That's it. So, and for this nice functionality. Also, I implemented some tests. So not just as a unit test, we need to test it here. So how the things are working. To do that, we need to go, I did this one previously. I went here to the JSON schema and I just used some of this property and try to evaluate them. Let me also bring the test case here. I'm going to put in the source entry schema test. Source entries, and I need to have a schema folder. And okay, source entry schema test data. That is great. So let's see what's going to happen in reality. As you see, I created some valid and invalid data. Look, what is the difference? Width and height, you can specify what is the format. Look, for example, these two versions are, one of them is valid, one of them is invalid. Valid one, weight and height, they are number, and invalid one, they are string. So to learn about all JSON schema, please go and read the document that they tell you how to create the property, complex property, how to write the business logic a little bit for evaluation or something like that. So, but right now for test, I just created invalid data. I changed something that to test the whole scenario, and invalid schema. Look at the schema. For example, type is Boolean, but if type is non-valid type or any type, it's supposed to throw an exception. It's not supposed to be working. So that's it. So in the utils, I'm going to define mode as a parser. Okay. Guys, if there is any question, let me know, please. Interrupt me, please. Oh, cargo test. Let me, cargo can't find any test here. It's supposed to run the test because we implement test here in the parser. Yeah. Take a lot of time. So I think we need to pause the video for this time. Let's pause, and when it is finished, just come back. So we are back, it is working, and it was slow, but let me share the screen and continue. So yes, we were here. Actually, it is running the test properly. So there are two topics let me mention. When I'm running, because I'm just implementing the test, so I'm not using them. It is asking that actually, if it is not there, you will see. Let me also comment to show you. When you can use the deadline. Actually, this attribute ignore if you have a code that you are not going to use it. Cargo test, if you are running, oh please. So it is running this. If you have this issue, it is because of the actually Rust analyzer locking the file actually. So I added the allow.code because I'm not using right now them. You can add under this one at the beginning or allow that code actually. So by the way, it is the test. If you would like to implement, and again, it is fetching the whole anything from this. I don't know what. So it is the test for your unit test. You can define your unit test. You need to go for a superstar. It is a must actually. And for a reading file and buffer. And so I'm using these two actually core library from the Rust. So I implemented the helper function from the current directory, go and fetch the file path and actually path buff, and then read the whole file as a string and validate JSON schema. And it should be true. If it is, I'm reading the valid JSON schema, and if it is valid, validate schema supposed to validate it, that is true. And as you can see, it is true. So, and for example, I implemented a scenario for the invalid schema. I'm sending invalid schema. What is the invalid schema? It is here. I'm reading the invalid schema. So it should be Boolean, and I change it to non-valid type or any type that you can put. So because it is not valid, the valid schema is gonna return false. So I implemented the fourth scenario. A schema is valid, the schema is invalid. Data and schema are valid. And as you can see, so I created valid data for the valid schema, and also I created invalid data for the valid schema. It is invalid. And again, as you see, so the tests are running and passing. It means I'm reading the two file, I'm validating the schema, so and valid data. So as you can see, this scenario, valid schema, not this one, valid schema and invalid data, and also work. You can review the scenario. That's it. The helper generally is not a big issue, and that's why we are going to finish the topic of parser helper. It's really important. We are going to use it a lot, and it's really important for having it at the beginning. So let's finish the job of the schema step by step. Let me kill out extra windows here and go step by step to the schema. And it is a lib. We are here so far. Last time we created a schema with the input DTO and bash. It is working pretty nice. So let's go and finish the test for this one with a new scenario that show you what the change we did here. It is nice and it is good. So here I implemented this one. Install to agent. Install agents app. I'm going to at first to change the test scenario we implemented. So it is the old version. Okay, let me refactor this one. Install app agent. So here we don't need in the old fashion the things that I implemented. It means we are sending two names, Alice and Bob. Also, there is no need even. They can be, sorry, it is array. They can be also hard-coded there, but I implemented in that way. Install app should be imported here. The previous one was install agent app. It is agents app. Maybe we need to change the name a little bit. So here this function, as you can go here, let me go for the brief explanation what's happening. It's receiving the conductor, it's sending a configuration config, which is the fixed code. Actually, it is the conductor agent. It's starting for the actually admin panel. It is asking this one to generate two keys. One we are going to use as a developer, one we are going to use as a non-developer. So how we can distinguish between a developer or non-developer? Progenitor pattern, we are putting one of the key inside the DNA property, review the previous video, and then we create two install app requests, and we are asking agent or conductor to install two requests or two instances of a DNA for us. So, and then we are going to have one instance, this one, which is developer, and one instance that is not developer. So we are sending back these two cell, or it is better to say two agents here. I'm gonna call it Alice and Bob. Let's see how it can help. So scenario number one, a schema definition right now fake. We are not adding the definition to the business logic. Right now, let's change here. Alice calling Alice. Alice is going to call parser. Actually, let me create something. I'd like to create actually let me show you that what is my actually array. You know, we are going to have a const in zone function. We are going to test some zone function here for different one, and we are going to copy and paste. Do not copy and paste. We can say create a schema. The name of function is create a schema. That's it. It is just for to not copy and paste the string over. When we are changing the name, we can easily just change one place. That's it. Not a big deal. Right now, create a schema, not, and then we can say right now it is enough right now. So the name of zone, that also is create a schema, zone function, create a schema. So Alice creating this one, and we are waiting, and it was the old way. You remember we called this function twice in the old version, but we don't need anymore this line because we can say, so let me comment the rest and go step by step that we can see how the things are working. I would say that constant Bob create the schema result. Wait, Bob is going to call Bob. Yes. Bob is going to call. What is going to call from parser zone function, create a schema, and it is a schema. So that's it. What we are expecting here, based on the installation scenario, we assume the first one, Alice is developer, Bob is not developer. It means here, Alice suppose can create and Bob cannot. So do you remember this scenario? Let me go back here. Alice is a developer. Developer should be able to create a schema. Validation JSON schema later. Another agent, as a normal agent, we are preventing them to touch a schema, edit a schema, or delete a schema, or anything. We are going to implement this business rule today. So it means Bob is not developer. Let's see what validation, what case study is supposed to be here to test. But about the validation, we implement. Look, create a schema. If a person who is running the code is not a developer, to run exception, otherwise create a schema. Let's finish the scenario. Let me run. Oh no. Oh, I forgot to log actually. anyway to run exception for sure. Oh, it's going to run a lot of tests, but wait. Right now, all the tests are being run actually. So before continue, let me comment the extra tests that we can speed up the process. Generally, we need to run all the tests, but let me comment them, and then we can. So what happened here? What is the error? One fail. You are not the developer, so you cannot. Can you see, guys? It means exactly because let me also again rerun the test. It means here we receive the exception here that you are not developer. If you would like to test any scenario that's supposed to return a specific error for you, follow this pattern. Let me show you. We didn't have enough time to cover it exactly in detail, but today we are going to do that. So I'm going to call this one. It means if there is exception, we know there is this exception. It should be exception. So I'm going to call the function here. And also there is no need. We are calling t.fail. We are this one, we are throwing fail for try that coming to cache here. So lastly, to just rapidly everything working, I wrote this one, but there is a better way because we are waiting for a specific error message. We are waiting for this error message. If it is not this error message, also the test is not supposed to pass also. So how to run this kind or to test this kind of scenario? Let me also bring this one. It means you need to say t.deep equal, let me bring it here. What is deep equal? E, and look at the message. Yeah, it is the things we log in. Let me show you guys. Let me show you. It is E is coming here. Yeah, I'm going to log E. E. So it is passed because I didn't put anything. It is try cache, you know. So here we need to write E if t.deep equal if E point dot data data, it should be exactly equal to this one. That's it. From backtick to backtick. If I receive the exact same scenario, I would say yes. We are waiting for this scenario. this one. I want to ignore this one. That's it. That's it. It passed. Two tests are passed, actually. It means we already have one DNA with two agents. One of agent is developer that able to create a schema, and one of them is not developer. And if Bob tried to create any schema, so it received an error. With extra point, I'm going to continue. As you see, the validation that I implemented, that it is here inside the zone function. But in reality, the developer can easily, or any agent can easily cheat this one and actually just overpass this logic and sense. So this validation rule that you see, it is not a finished job. We are in the peer-to-peer. Let me come here and to tell you important point. It is for the future. Yeah, we are in the peer-to-peer distributed world. So the same validation is supposed to be run everywhere. In Holochain, we have a place name, a validation rules. So it is the same validation rules supposed to be run in every agent machine. So if anybody else cheated, supposed to send a warrant and notify others, hey, we have a cheater. That validation rule is not exactly this validation rule I implemented. So it is the first step of a validation rule in a zone function. It is just running after the action, after the UI that you are doing, but it is not enough. What about that validation rule? That is a complex scenario and a topic. I'm gonna cover it later. So do not look at this validation rule as a finished validation. That's it. Do you have any question, guys? So next step. What is the next step? We are going to add extra layer here. It means we need to create a schema, receive a schema detail, this two one, and create a schema. We are going to evaluate that the definition is a JSON schema or not. I'm going to implement on a schema detail. Let me see how much time we have and bring the things step by step or not. So we are in 1 hour actually. Let me do a little bit also copy and paste here and explain on the code instead of typing. So for the validate, I'm implementing a function as a validate on one instance of the input parameter schema DTO. Result can be anything, and a string, it is the error that we are supposed to receive. So what I'm going to do, I'm going to say I need to have a list of messages. It means anytime UI sending a schema DTO, we need to evaluate. So for step by step, I'm going to say, okay, I need to have a message list, then a result as a flag. So let's go for the caret helper parser validate a definition based on the parser that I implemented. Yeah, so it means I need to also bring parser in the lib node parser. Have it in helper. So yes. Helper parser validate this one. So we haven't finished it. I'm going to remove these two from right now. Enough to have them because I'm going to use them. So validate input the definition, self as a definition. You know, guys, that when you are implementing any function on the struct with the self, it means it is not a static function. It is a function on one instance. So self, it means it is me. So if it is not valid, we are sending back, we are pushing a one error message to this one. And so I created an array of messages to review all of them and then return like a function. If it is not, I'm not going to return like immediately after any message. It is the reason I'm creating the array list of the errors. If version is empty, push error. Version is not supposed to be empty. And then at the end, if result is false, return and join all the error as a new line and just return error. Otherwise, return okay. It means during the process, we test these two sections, validate the schema, and this one shouldn't be empty. That's it. Then we can say here, if let input and validate. Do you see? If it is return error, or let's return like E actually. Let me not go to short version that you see. Extend result return back was an error. Was an error with a guest. You can. So that's it, guys. It means right now we evaluate everything against the JSON schema. Right now, if I rerun the test, for sure, the first one is not supposed to pass because the input parameter is not in a valid JSON. But the code is still, I'm not using this one. Validate data. I'm not using this function. That code was because of this one actually, but this one also working. It means ignore. Wow. What we have here, can you see, guys? Exception unreachable. It is unreachable, but why we send back the, I expected to see the exact same exception. I'm gonna review this one, but let's fix one. So what happened? We are evaluating valid schema, but in the test we are sending the invalid test here. The issue is here. So what I'm going to do, I'm going also to bring this fake data that I used for the unit test here. So I'm going exactly to send a valid JSON to see everything is working. So let me improve the test. So I'm going to say read file. So join directory in the test data, valid JSON. So read schema file. I need to import fs.
You do not need to await, I think, before that file sync.
File async. Why not?
Because it's older than the promises, it's just sync. No promise. It blocks the system.
File sync, it is not async. Okay, so
yeah.
Right now it is a schema file which is reading from a valid schema. It means I'm going to send this one. Sorry, valid schema, this one, yeah. So let's come back here and instead of sending a fake data, let's send a schema file. And here it is working. And right now the test should be passed again. Bam. You see, as you can see, if I send invalid data, it means this one is invalid. Anything. That JSON schema cannot pass it. If I test it, it is not working. It means invalid. It's supposed to be exception. And I can also implement exception like this scenario. It means send the invalid data with exception, but it takes time. I'm not going to do that. And as you can see, a schema definition is not valid, as you can see here. So we can exactly implement the same scenario here. And let me go back here. It can be to-do list for you guys. You need to implement this try cache with the same scenario that waiting for this one that it is not valid, that send that it is not valid. But I'm gonna right now comment it out. So that's it. What scenario we have? We are reading fine. This one. Developer can create a schema properly. Non-developer cannot create any schema. This is it. Let me stop. So, yeah, we are after 1 hour, guys. Any questions so far? I was expecting to go a little bit more, to go and review Anchor. I think this week we cannot do it, but it is good. We have a good topic for the next week about the Anchor pattern, how the Anchor is working, because we create a schema, but we didn't fetch a schema and test that is that created or not. It means we didn't drill into the DHT and fetch the data and test it actually right now. But we can do it for the next week. Do you have any question? I think we implemented. Go ahead.
I know, but maybe it will be after because it's not related to the content of the session.
Let me test because we have enough to test. Wait, let me test this scenario also. It is nice. For me also it is nice. Let me test this scenario. Because we have a get schema element, yeah? It means if we send this one, we are supposed to receive exactly. Okay, let me implement this test that be sure that this one exactly working the same. It means, oh, if, I'm going to say that let or const that Alice read element. So Alice call share zone, and we are going to call this function. Let me add it to the constant. Okay, we are going to call get schema element. Zone function, get a schema element, and I think it was a schema, as an input, yes. We are sending a schema as input, okay. Let me log it. Alice read element. And let me copy this for Bob. Both of them supposed to be able to read the same element schema actually. And then Bob element. Let's use the so wait here, delete, can wait also here, and both of them should be okay. T dot okay for Bob read element. Okay, it means we have received something without any error actually. Alice read something. So if both of them in reality are in the same DNA, Alice created a schema and Bob can read it. Both of them are supposed to read the same schema. It means everything is up and running. Let's run. Pass. Bob read element. But wait a second, I forgot to change this one. Bob call get this one. So it's not a valid. So cannot find a schema. On Bob. So that is beautiful. It means there is a bug here. So did you get the point, guys? Anybody would like to guess what's happening? Here, when we are creating the hash entry that the element we are going to see in the network, we are using the schema that new. So here, owner address is a developer address. But just imagine, I love the mistake. I love the mistake. We can learn something here. So how the schema, how this function is working, it is reproducing the same schema as a struct and asking the DHT, give me the content and element for this hash from a DNA actually. So when Alice, because Alice created this schema, Alice generate this one with what agent ID? With Alice agent ID. So this one is coming from the agent, the agent public key that's running. So it is not correct because when Bob is trying to fetch the data here, it's supposed to say, hey, the real schema is the schema with this definition, version, and the owner address is not mine. The owner address, it is from Bob. It means we need to duplicate this one. Oh, it's really nice mistake. New with key, for example. Yeah, we are going to owner address. That is owner address agent pub key. It should be injected from outside, actually. And here we should say, when you're creating this one, you need to send this one from where? Anybody can guess where should I take this owner address? Any guess? Owner address.
DNA.
Exactly. We need to read from a DNA properties. Exactly. Thank you. It means it is a DNA property get that developer address that we need to send. And here the developer address, here we have agent pub key 64. It is a base 64, but we don't need base 64. We need to agent pub key this one. We need exactly this one. Wow, it was a beautiful mistake. From so what is the issue? New with key. That is it. So please let me know if you still have a question, because it got a little bit complex, but if you have any question, please let me know. This one is supposed to work. Wow, passed. So it means Bob read the element that Alice created. So it means, Nick, we already support the scenario of having a multi-agent in the same DNA.
We're getting close to the integration test.
Mm-hmm.
We're getting close to the integration test.
It is integration test, actually.
Yeah.
And the unit test of DH, actually, it means a holochain for the DHT. We can also have a unit test. I'm going to postpone it for later, actually, not for now. So I hope you already understood what is the topic. Otherwise, we can discuss it later. Guys, we need to wrap it up the video and we can continue our discussion if there is any more. If there is no question, I can end and terminate the video, the recording version actually. No, I can say bye-bye to visitor and we are gonna a little bit continue talking to others. See you next time. By the way, don't forget please to send your feedback in description. Anything, any topic, please just notify us. Bye-bye.